I wrote this essay called Abstract Processes when I was thinking about science, and I was thinking about space, and I was thinking about the universe. And I thought that I would share this essay because I find it to be very hopeful for understanding the human condition, and I find it hopeful for understanding our place in this world and in this universe. So yeah, I'd like to read this essay for you today. It's called Abstract Processes. So without further ado, let's dive right in. The universe is a big, big place. It's easy to feel swallowed up by it, on bad days, but it's also true that it's a giant place of pure wonder and potential. There is so much to explore. Cosmology is one of the curious branches to emerge in the study of science and astronomy. Cosmology started with the deep interest of the pre-Socratic philosophers who asked questions about the universe as far back as ancient Greece. Where did the universe come from? How did it originate? While some of these notions are obscure and often very abstract in modern times, the idea that the universe is an entity to study as a large-scale phenomena, and that the universe should be explained using scientific, empirical, and mathematical terms, can be traced back to the early study of cosmology, of daring to ask the questions. The depth of Galileo's questioning of the geocentric model of the universe, as far back as the Renaissance, has forced us to ask questions about what the universe really is, and all of its strangeness and science and mystery. The answers are not usually straightforward or intuitive, but this is important. The universe is constantly defying our expectations, where physics is always patterned, but not always easy to imagine, particularly on the scale of the universe. So the question is, where and how did the universe originate? What is the scientific and mathematical explanation? When working through cosmological principles as postulated by Stephen Hawking, one discovers that the cosmological aspects of the universe are often complicated and very involved. What we think of as the universe is really a multi-layered phenomenon, and asking questions and exploring seems to be the best place to start. Indeed, the principles governing our universe don't often make immediate or intuitive sense. Imagine, for instance, constructing a solar system closer to the origin of our own solar system. The solar system is not easy to design, a solar system that actually works. The laws of physics defy our imagination, but it's nonetheless fun to think about. An early solar system might make sense if we keep in mind principles of gravity, but how that plays out in real life can be difficult sometimes to imagine. There are rules that govern our physical universe, but they are complex. We talk about life as a phenomena in the universe, and life itself is an extraordinary thing to behold. What would life be like on other planets, other solar systems? Humans on Earth require water, but what if there were species in the universe that didn't require water, in the same way we imagine for us humans on Earth? Could there be carbon-based life forms, for instance? In what way would life actually form? Even simple life itself would be fascinating to study for what it can show us about the origins of life. Extremophiles are remarkable creatures that can exist in extreme spaces in the world, such as life forms that exist in the very hot vents of the deep ocean. Could the universe be full of diverse creatures with different chemistries and makeups? Are other organisms out in space extremophiles? Life is always a fascinating structured thing when breaking down the components. Matter finds ways to become biological. Life is an organizing principle in a universe of entropy. It's fascinating. We can only imagine what life would look like where organisms can thrive and exist in such extreme places as other worlds. Life in the universe may not always be familiar to us either, and this is interesting to consider too. Is there life in the deep ocean of Europa? There's definitely potential for new life forms and for realizing the complexity of biology and how life exists despite the forces of the universe. Such questions are all astronomical because they deal with the universe in fundamental ways. To return to cosmology, asking questions about how the universe came into being and how it will be in the end have fascinated thinkers, scientists, and planetarium enthusiasts for quite a while now. Using logical principles is a good start to understanding this process of cosmology and how people can postulate theories. Will the universe as a whole implode one day? Will we be able to even envision deep time? And what will happen during extreme points of time in the future? Will there be other Big Bangs? Is our universe really part of just a series of multiverses? Understanding ourselves in such a grand scope of such things might seem less likely in some ways, but it's good to remember the complexity of processes in our deep existence that baffle even professional physicists and scientists, and it's good to be reminded of our place in that scheme. Material views of the universe are commonplace in science, and this is important for gathering empirical evidence. Math requires us to consider the world through abstract numbers. And in general, when speaking of science, some principles are abstract. One fascinating thing about all of this, though, is that through what could be called abstract processes, processes that can be separate from our immediate experiences, are happening all of the time around us. Through studying the complexity of these processes, we more and more understand how the universe functions. But we're far from understanding how it all really plays out, and there's wonder to realizing that. It's fascinating to consider. Thank you for watching. I hope that you enjoyed this essay. I hope that you'll check out my other videos on my channel. I'm Phoenix, thank you for watching, and I will see you next time.